As you can see, I already have some code written already, but don't worry, I will explain what it does. So first of all, in this test session, we're training a machine learning model. We have finished our data preparation, processing, and everything. So I'm just training. We could just call it NLP model to be more explicit. Okay. Um, and before I continue, before I explain all of this, let me go to this side and explain what all this is also about. I remember in a previous lectures we talked about um, some metrics involved in machine learning to evaluate how a learning model is performing against some metrics. And the metrics we mentioned the MSE, mean squared error. I've seen mean squared error on the other Hanson, and we also talk about confusion metrics. So these most of these false positive, and you're seeing two positive and all of them, most of them they constitute the confusion matrix, but we explore them in detail. I will explain all what it's about, so don't really worry about it. Let me create a new code. I think that code, no, let me just try to use some code here, the code block, so I can come comfortable with the code block than markups. Sorry for that. So the first one let's talk about false positive. So first of all, for us to explain this, we have to create a column, and the first column is actual outcome and predicted outcome. So I think with this explanation, you should understand all what this means: false positive, true positive, and false negative of them. So let us focus on the first one, which is false positive. What false positive means that it means that the actual outcome was one, for example. Actual outcome was two. We say two point one here, but it predicted zero. That is what we call the false positive. Sorry for this full stop. It's going to like yeah. Think okay. So that's what we call the false positive. Let's put the false positive. Okay. So false positive is the actual outcome was one, but it predicted zero. So that means it failed. It failed the test. And then the second one is true positive. True positive is the actual outcome was one, and it predicted one. Okay. So let us tag it as true positive. And the third one is false negative. It means the actual outcome was zero, but it predicted one. So that's what is called false negative. Okay. The last one we have is true negative, and true negative is that the actual outcome was zero, and it predicted zero. Okay. So that is basically that's what um this is all about. So we use this to generate a very comprehensive matrix that we work for machine learning model and see how it's doing. So when you combine, as you can see, when we combine the two positive with also the false negative, we have what we call the two positive weights. That is to show how correct. Basically, the two positive weights shows how correct the model is, how suitable the model is. Then this false positive weight, it shows the deficiency of the model. Like it shows the deficiency of the model. So that's what it basically shows. It shows you the deficiency of the model. That's what the false positive weight shows. And the false positive weight is FP. That means false positive divided by false positive plus two negative. So it's basically this is the message that we use for this. So we said again that two positive weight shows cares about, it's also called the recall. It's also called the recall. It cares about how suitable the machine learning model is in predicting the right thing. Why this other one is a deficiency, um how bad the machine learning model is doing. So if your FPR, your false positive rate is so high, it means your model is not um, good, efficient. So let's look at the model. Let's look at how we train the model. We know the counts. This is the data frame that we created. I think I made them. I think I need to put a tab here. Do this. Okay. So that's our data frame, and that's our target variable that we formatted into zeros and ones. Then we're using logistic regression where we imported it. And then this cross verb predict is something that I may be confused about. Because we don't have a test data. So I didn't want to like split it the way I did the last time. But I just use this model in sklearn. And what it basically does is it kind of randomly samples and data that you use for his training and test. It's really kind of very complicated and involved, but I don't um, I don't think you need to know it very deep. I don't really expect you to understand it so much, but it's just basically the resources on the variable, like we pass in the variable. This CV means three, so that means we're going to like sample it three times. We're going to divide the data set into three places and then use some parts for training and some parts for testing. So it's called kind of called a cross validation. Yeah, cross validation. I'll put a link into the video where you can like get more intuition about it. Yeah, so we use the logistic equation we call the instance, and we pass this class with what class is trying to do is that because our data is imbalanced, so we are trying to make it balanced. So the machine learning model doesn't skew it like be kind of more sentimental towards the majority class, which is the zero. From I think the zero is majority class, yes. So we put that balance, but we see in the next very soon in a second how we can also like set a penalty to punish the the I think is it punish the right word to use, but we just kind of kind of penalize the majority class respective to the minority, so that the machine learning model take can have that balance a little bit, not kind of be more skewed to the majority class. And something about machine learning I didn't talk about is biases. Bias is something that is uh, that you use to not allow the machine learning model to be kind of to be segmental. You add a variable to it to kind of wage it a little bit. Yeah, so but you don't need to worry about it. It's when we enter into deep learning and AI, you work with more biases. But for now, biases are implemented in the logistic regression, and is done for you. But this I'm doing this cross weight and balanced is also like a bias. Yes, trying to make it more bias. So let's make it bias, like not to be. It's not the bias means in this sense is you're not making it to be skewed towards the majority class and make his position based on that. So we all know we call the methods. So we don't have to use the fit method again. So cross validation predict already has the fit inbuilt in it. So we just pass it the our instance of the logistic regression, and we pass in this and this, and we pass in our test string, this our CV, that is cross validation stuff we talked about. Then the prediction we convert it to a series. A series is a one dimensional pandas object. Data frame is more than one or two to be more precise. So we can see our false positive, and we can see actual outcome is 1 0. So it's saying even the prediction equals to 1 and equals to 0, and that is the length of the is now going to return the length of the false positive, as you can see. Then we are when the positive equation equals to 1, which is correct, then that's it. Then that's the length of this of the two positive. False negative 0 and 1 if it's equals to, and then that's the length. We have the length, and then we have this one, 2 negative also, same. We have the length. So now to find the true positive rate, that is how efficient our model is in predicting the right thing. We use TPR. We now call the true positive plus the false negative. Okay, and same for this. And then let us run this and see how our model performed. Hopefully we have no error. As you can see, true positive rate is high, 0.859. That is 85%, or that's of 85%. And a false positive rate is 0.016. So that means our model is very efficient, because of, like I said, our false positive rate is very low. So it's showing that our model is okay. And like I said this earlier on, your true positive rate plus your false positive rate will be equal to 1. So that's something you note about. It's equal to 1 because it shows for the deficiency of this, if there's any deficiency at all. So our model is really doing well. But in the next session, we're going to introduce what we call penalty to penalize our machine learning model based on the majority class. Yes, to kind of misclassify the majority class, and because it has more data point, it has more percentage distribution than the minority class, which is the one. So in next session we see how we penalize it, and penalize it for misclassifying the majority class, and then we'll now see how it affects our metrics. Thank you very much, and see you in the next lecture.